Hello, everyone, and today I am going to go into more detail about the potential severe weather setup we have tomorrow across the Ohio Valley here. Um, Not much has really changed in the terms of location, location-wise here. I think Pittsburgh, um, all the way up north to Pittsburgh, down to Charleston, even Lexington potentially. I think Lexington, yeah, Lexington is barely in that slight risk as well. Cincinnati, Columbus, much of West Virginia, central northern West Virginia. Um, this is where our highlighted risk is here, level 2 out of 5 still. Here's our tornado risk. Yesterday, um, the short range models weren't in yesterday when I made the video, and I had said that the main tornado threat would probably be a little bit further west than what it is now, closer to Columbus, Cincinnati. Um, I mean, maybe up to the Ohio River, up somewhere in this sort of region, is where I thought the best tornado threat would be, but it's shifted sort of east now toward like Wheeling sort of area down through Athens, um, almost into the Huntington area. So this 5% risk here, very interesting actually. Sort of very interesting setup we have. I could see that possibly even increasing um, if certain trends go that way. And I will talk about that later in this video. Here's our wind threat here. Essentially the slight risk. The entire slight risk area is going to see a potential damaging wind threat. Um, and I will also go over this as well. But this will be due to the uh, pretty intense mid-level winds and low-level jet as well, which I will show you guys. And then here's our hail threat, slightly condensed in compared to your wind threat here, but still mainly that shift northward with the hail threat. But I-64 between Huntington and Charleston, northward, Lexington, Cincinnati, Columbus, Pittsburgh, Morgantown, Parkersburg, Athens. Um, yeah, potential for some large hail. At first, I thought the hail risk would be I thought there would be a hail risk, but nothing maybe more than I don't know what just happened there, but I don't know. I didn't know it would be potential for larger than quarter size hail with some of these storms. They do seem to have that potential for tomorrow. We'll see how that kind of plays out for the rest of the day. But here is our again, here's just our main risk and that marginal risk to Baltimore, Washington, D.C., Louisville. So, interesting setup to say the least. So, first, um, well, before I go over any sort of upper air maps here, I do want to say there are two things in this setup that I think, um, well, really one thing in this setup I think could limit the severe weather here. Um, and that's going to be the lack of instability here. Um, or CAPE, which I will go over, but the lack of instability could be an issue, and then our elevated mix layer also could be an issue, and that's just sort of just a layer of dry air um, sitting at the inversion. So this the stable air mass in our atmosphere, and the heat rises and our instability rises at the surface, those air parcels want to rise and go up, but they can't because of that stable air. So the more energy that builds up, the more chances it can break through that stable layer. And depending on how strong that stable layer is, really depends on how intense these storms can be and can get. Um, and that's why I think this event could have it could either be almost nothing or it could be a few long track supercells, potential of tornadoes for an hour or two across northern West Virginia, um, eastern Ohio, southeastern Ohio. So it's going to be a very important thing to sort of iron out here in the next 24 hours. Both of those ingredients, and sort of phenomenon. So let's now look at the 500 millibar wind map. This is an ensemble mean. So this is just taking, I believe, five short range models, blending them together, and spitting out a kind of blended output here. So I'm going to just advance this. Oh, let me switch it, my bed here. Just going to advance this. Um, so this is Monday. This is Monday morning here. We can see our close low, northern Wisconsin, sort of Minnesota and the Great Lakes here. That's our close low. We can see our at the base of our trough here. We can see our enhanced jet streak at the 500 millibar level. Um, as we move on throughout the day, that jet streak kind of gets pushed towards the Ohio Valley, and this is by about 2 p.m. here. Um, Storms will be beginning to initiate by at this point, sort of in the Columbus Cincinnati range. So they're going to be sitting in this sort of 70 to 80 knot wind um, at the edge of it here, at the jet streak. So as that convection starts to form, it's going to be in pretty good position on the 500 millibar wind here. As we move on throughout the evening, this is at 7 p.m. Most of that convection will be kind of moved off to the mountains, but again, still in that sort of 60 to 70, 80 knot range um, across Pennsylvania and West Virginia. So our 500 millibar winds look pretty solid here. I mean, nothing too crazy, but definitely very sustainable for any sort of severe weather. Next, I want to look at our low level jet here, our 850 millibar winds. This is going to be a better map to kind of sort of represent our low level jet. And our low level jet can really increase our damaging winds in large hail threat. They could also, it could also support supercells as well. So this is our low level jet. This is Monday morning. Monday morning here. We can see our close low. Um, it's further east here, just because of the different heights, but same general location. As we go in the morning here, and through our early afternoon, this is about 2 p.m. Our convection will be starting around Cincinnati, Columbus, but out of ahead of Cincinnati and Columbus, we have a nice pocket of 30 to 40 um, knot winds at that 850 millibar level. So we'll see how this advances here throughout the afternoon, and by like 4 p.m. here, we can see those 40 knot to 45 knot low level jet winds start to increase as it moves into the Ohio Valley. So as it moves into eastern Ohio, Kentucky, sort of western West Virginia, that low level jet seems to seems to increase in speed. Anything really over 30, 35 knots is going to be sustainable for thunderstorms, even perhaps severe thunderstorms. When you get into that 40 knot range, um, that's fairly impressive, especially sort of for this time of year. If we had more instability at this time of year, I think this could be a more significant setup. Um, but it's fairly impressive with the sort of weaker low. It'll be around 995 millibar, maybe potentially a little lower as it moves across, the Great Upper Great Lakes up into Canada. Um, so fairly impressive low-level jet across the region in the Ohio Valley from really southern Pennsylvania through the coal fields of Kentucky. This is Monday evening around 6, 7 p.m., where that line should be sort of entering well into the Appalachian Mountains. All right, so next I want to just kind of go over our dew points here, and there's going to be a lot of discrepancy here, and I'm going to show you, especially in our temperature. Um, the higher the temperature is at the surface. We got to remember, the higher the temperature, the more energy is there to break that cap layer that I was talking about. So some of these models are about 10 degrees cooler compared to some other models, and I will also, I think I'll show that first. Um, so this is the HRRR. This has been one of the more bullish runs for this setup. Um, but I'm just going to show you the temperature. So this is Monday around 10 a.m. 10 a.m. right here. 69 degrees, Huntington, Charleston. 70 Cincinnati, 66 Columbus, 66 Parkersburg. So pretty warm at 10 a.m. As we move on to the afternoon, 1 p.m., 2 p.m. We can see our convection sort of begin to bubble up here. Cincinnati, Columbus, even some across central Kentucky. But look at our central West Virginia, western West Virginia, eastern Ohio, eastern Kentucky, where temperatures are bordering 80 degrees. Keep that in mind. Keep that in mind. And as you know, we can see that convection sort of cool our temperatures as we go through the evening. All right, so here's another example. This is our Wharf ARW model. It's used fairly well enough to just kind of compare uh, with other models. That's what I use it for. But one thing I noticed with this, by 2 p.m. At 2 p.m. here, we have the same sort of situation where our low 80s are possible, high 70s especially, but even some low 80s, Charleston low 80s. So our ARW model, Wharf ARW model, is also showing that potential 80-degree mark as well. Let's look at the NAM 3K model here. So by by about 2 or 3 p.m. here, it's a little cooler, low 70s, even some mid 70s. Around the Huntington, Coalfields, central West Virginia region. It's a little cooler, but still not too terribly off. But if we look at our see our FE3 model here, this is the same time. This is the same time. This is Monday around 2 to 3 p.m. in mid 60s. You know what I mean? So there's there's a few outcomes that could play into this. It could be mid 60s, it could be, low mid 70s, or it could be closer to low 80s. So, the higher the temperature, like I said, the more energy, and that's going to play a crucial role in the setup. It's going to play a crucial role in how on how really severe the setup can get. Okay, so I showed you a an issue with the setup. There's quite a few models showing cooler temperatures, quite a few showing warmer. I'm gonna look at the dew points just real quick here. Now here's the H triple R. And then this is Monday afternoon by 1 p.m. We can see that our very thin warm sector that I had talked about yesterday, it's still present. It's still going to be very thin. It's still going to be very marginal. But as we move on through the evening here, I think the prime time here is going to be around like 3 to like 8 p.m. Across the Ohio Valley, maybe even up to 10 p.m. further eastward. But this is around 5 p.m. here, and we can see our little warm sector, low to mid 60 dew points up through Morgantown, even close to Wheeling. Parkersburg, 64 degrees dew point. Um, Decently impressive. These dew points are impressive. Um, let's look at the FV3 model here. Let's see what that is showing. And what we're gonna find out is actually a lot of these models are have a pretty good agreement in or in our very thin warm sector. This is a little weaker. Low 60s, barely reaching Parkersburg, West Virginia, Huntington, West Virginia. But you gotta remember, this model was like 10 degrees cooler than most of the models I had shown previous. So that's going to affect our dew points by easily 5 degrees possible. Look at the NAM 3K dew points just to get a better idea here. The NAM 3K is, I mean, that warm sector is, a lot more wide in the Ohio Valley. We got that thin but sector here that used to kind of extend up north, eastward, but with the HRRR, the FE3 model, the NAM has this more broad warm sector here with mid 60s present from Cincinnati, Columbus, Lexington, Charleston, West Virginia, Parkersburg in the low 60s. So very interesting as we move on through the evening. That warm sector just advances eastward, mid 60s, Huntington, West Virginia, Charleston, West Virginia by Monday evening. All right. So next, I'm going to show you the surface-based cape. This is just again, this is fuel for any sort of thunderstorm. It's very important to compare this to the other models. Okay, so this is Monday by 1 p.m., 2 p.m., and we can see our convection will be probably right on this uh thin line here between zero essentially and around 1200 to 1500 joules per kilogram of cape. Um, this develops in that sort of warm sector, and by about 4 p.m., the most of this surface-based cape is going to be up through Morgantown, sort of east of Morgantown in these valleys. But central West Virginia, southern West Virginia, still seeing 1,000 to 200, 1250 joules per kilogram cape. So that's not very impressive, not very impressive at all. But the nice shear values we have in our mid latitudes and our low level jet um, definitely can work with this low amount of instability. Let's check the NAM 3K. So the NAM3K, um, you can see the broad warm sector here with our cape, even approaching 2,000 joules per kilogram. That would be very sufficient enough. That would make this event slightly potentially worse. As we move on, this is about 4 p.m. here. As we move on, it's about 6, 7 p.m. Most of that higher cape is going to be situated southern Ohio, central West Virginia, where that 1,500 joules per kilogram cape value is going to be more likely in that region. Again, mix that with the very um, reasonable shear values. You're gonna get some pretty decent storms, damaging winds, some large hail, and even a supercell or two. Another value I do want to show. This is our energy helicity index. What is this? Well, this combines our CAPE and our storm relative helicity, which is potential rotation in a storm's updraft, which is needed for supercells and tornadoes. Um, but CAPE, like I said, is also that fuel for thunderstorms and these supercells. So it's a very good index to kind of sort of get a good idea where those will align. This is from the surface to our 3 kilometer range, so 33 kilometers in our atmosphere. This is 2 p.m. 2 p.m. Monday, and we can see our heightened values sort of Cincinnati south. But as we move on into the evening, it sort of bubbles up quite a bit here in southern Ohio, central eastern Kentucky, southern central West Virginia. Um, Fairly impressive, sort of for this low instability setup here. Um, but this definitely supports some potential supercell activity, especially in this, I think around this 3 to 4 p.m. range across central Ohio down to southern Ohio, especially maybe even northern Kentucky. But this sort of range through here, um, I think has the best tornado threat just from based off um, so far what I've shown. I don't know how far north. I think maybe Morgantown, even maybe I don't, Parkersburg. I think is just south enough, but Morgantown sort of straight westward. I'm not sure if the tornado threat's going to be as great up there. We'll see. Definitely has. I mean, it definitely has potential. Um, they NAM 3K has a nice 0 to 3 kilometer energy helicity there. So let's look at our HRRR real quick. One. And by the same time, about 4 p.m., we can see um, our heightened regions sort of again same areas a little further south HRRR. Um, Even a few pockets of some um, higher energy helicity up through eastern Ohio, but not as impressive as the NAM. It does kind of bubble up here, especially in the coal fields through the Charleston, Beckley region here up through the mountains. So interesting there. We can see some also bubbling up sort of northern West Virginia. So that's um, I could probably that's HRRR definitely has that sort of northern West Virginia sort of eastern Ohio threat energy helicity wise. But again, this is interesting setup we have here. I think the tornado threats will stay sort of um, minimal, but we'll see. We'll see. I think current day observations tomorrow will be key in knowing if the tornado threat's going to be heightened or not. So that's going to be something to look out for. I'm going to look at the simulated radar here. This is our HRRR. This is Monday morning, Monday afternoon. We can see our convection start bubbling up. And I mean, this is very impressive here. This is two massive supercells, northern West Virginia, sort of the Parkersburg region. Um, we could be seeing some capping issues, inversion issues, um, further south. Let's check a sounding kind of in between these two, see what we're seeing. Well, our photograph does have some curvature, nothing crazy though. Back it up here. Let's back it up an hour, see if we get a better idea. Um, I mean, our mid layer cape is okay, or three cape is not very impressive. However, our lapse rates, one thing I am noticing, the lapse rates, um, fairly impressive. That is very impressive. Um, so large hail, and that's why I was saying earlier, our large hail threat is definitely increased since yesterday. Um, and I think seeing those pinks in there are a good indicator for that. But again, this is just simulated. This will change. Um, and again, I think we'll have some capping issues sort of further south where storms may not even really develop. This is just according to the HRRR. Let's do the NAM real quick here. Monday afternoon, and we can see some, yeah, so we can see that convection from Wheeling, West Virginia, all the way down to Huntington. Let's take a sounding sort of in the Parkersburg region again here. Um, I am going to back it up because it could be contaminated some. I think this was good. Curvature not as defined as HRRR, but we still see some. We can kind of definitely see this in our surface winds. Not strong, but as we go up with height, they start turning clockwise. So pretty good, and we can see our surface to 3 kilometer shear 50. That's very impressive there, and with combine that with 1500 surface cape. Um, yeah, that's a decent tornado. I mean, that's not impressive, but for this region, this time of year, that is a pretty decent tornado threat. Um, and that extends sort of into the Appalachian Mountains there. So I think um, I think that kind of does it overall of what to expect Monday. I know I try to go over. There's a lot I try to go over at the same time here, so it could be a little bit frustrating. But um, I think the main risk here are damaging winds, 65-mile-per-hour winds, and half-dollar sized hail where possible. Um, that could very well dent up a car easily without any issues. So be weather aware, and tornado threat just really depends on how much instability can be built, and how high those temperatures can get. If they can get in the high 70s, that could increase the threat some. If that elevated mixed layer isn't as strong, if that inversion can be kind of sort of broke through easier than what's kind of modeled, then um, that also could increase the tornado threat. And I believe that National Weather Service, or the Storm Prediction Center, has even thought about increasing the risk of the slight risk here into a enhanced risk here. Probably for the Parkersburg, Morgantown, sort of Athens, Ohio region here. For that, maybe tornado threat increase and that hail threat increase to um, a 10%. I could see the hail being a 15% hatched and or 10 or tornado threat increasing to a 10%. But we'll see. We'll see. Um, Hopefully models kind of come into better agreements tonight. But I think this is going to be a case of surface observations, kind of just um, that, and then comparing models with sort of the morning sounding, especially out of Wellington. It's gonna be crucial for tomorrow's setup. Gonna be crucial. So I'll be looking over this again tonight. If I notice any changes, I will probably make another video, as this could be, um, like I said earlier, this event could be nothing, close to nothing, or this could be um, a fairly good event for this region this time of year. So until then, any questions, leave them below. Sorry, this was a long video, but there's a lot to discuss, a lot of things that could go wrong. So hopefully it was clear enough to understand. But if you have any questions, let me know. Until then, see you guys.